Hello YouTube, this is Frank from Happy Coder, and today in this video I would like to talk to you about how to use a JavaScript library by the name of Puppeteer to scrape data from the web dynamically. And after that, as a bonus, we would use React to render the data we have scraped from the web to the UI, this time around using React hooks to manage state and do some lifecycle events. And with that said, let's get into today's video. Just as some background information, the data we'll be scraping today is from megamitensei.fandom.com. And the reason why I'm choosing to scrape these kind of data, which is a list of the Shin Megami Tensei 4 demons, is because Shin Megami Tensei 4 is my favorite Japanese RPG. And the reason why I like it so much is because the monster designs are rooted in our mythological stories, folklores, and that lends a lot of authenticity to their monster design, to their character creation, to their character design. And I've been wanting to create a flashcard web app so that the player can get to know the plethora of monsters that the Shin Megami Tensei 4 or Shin Megami Tensei franchise in general offers. And if we were to create the flashcard assets one by one manually, naming, inputting the name of the demon, getting the image for the demon, and also penning our own description paragraphs for the demon, it could potentially take forever because, as you can see, this Shin Megami Tensei 4 alone, it features over 400 monsters. However, thanks to the megamitensei.fandom.com website, it has compiled a very nice list of the demons that are featured in the game, and we'll just be scraping the data for the demons for our own practicing purpose. We won't be using the script data in any commercial capacity. So with that said, let's get into using Puppeteer to scrape the data. So I've already created a Node.js project with npm init, and as you can see, I've already installed the Puppeteer package. And what the Puppeteer library does is that it allows you to do most things you can do with a browser within a headless browser environment, meaning you can pass a headless flag to to instruct your code to spin up a browser without a graphical user interface. But of course, if you choose to see how it's opening a tab and going to the pages, you can always instruct your code to execute the Puppeteer related code in a browser environment that has the graphical user interface. In terms of web scraping, from my knowledge, there are two very popular libraries. One is Puppeteer and the other one is Cheerio. After some investigation, I would say that me personally, I don't quite like the syntax of Cheerio because it looks a lot like jQuery. And personally, I prefer to work with packages that exposes their API so that the user can interact with the library with ES6 syntaxes. Because jQuery, the way it composes all the functions, it's very alienated. It's very counterintuitive. And beyond that, I also noticed that if the content that you're looking to scrape is dynamically generated with JavaScript, you would fare better to go with Puppeteer because Cheerio doesn't necessarily intercept the JavaScript dynamically generated content, whereas Puppeteer, because it's just a browser environment, it has the capacity to wait for the dynamically generated content to load and then scrape your desired content. So with that said, let's just try to compose a function that scrapes all these demon names and compile them into a nice list so we can use later. Inside of our IDE, you can see that in the index.js, which is the entry point of our Node application, I've already imported the Puppeteer package. Now let's define an asynchronous function by the name of scrape demon name list. And the reason why we need to define our function as an asynchronous function is because a lot of the methods that the Puppeteer library uses, they return promises. And if we want to use the async await syntax to work with the promises, we would have to define our function as asynchronous. Otherwise, we wouldn't be able to use the await keyword inside our function. We're going to call our function scrape demon name list. And because we already have the Puppeteer package imported, and first we're going to declare a variable by the name of browser, and this is going to be the browser instance that we're creating by using the puppeteer.launch method. And if we want to, we can instruct our code to create a browser environment that is not headless. So we do headless false. And after we have created the browser instance, let's create a page using the browser.newPage method. And this will open up a tab within the browser environment that we have created. And we already know that the URL that we are going to be visiting and scraping is this URL. Let's copy it and declare it in a variable by the name of URL. And within this new page that we have declared, we're gonna await the page to go to this URL that we have just declared, which is this URL. And I just want to mention that when you're using the await keyword without assigning it to anything, it simply just waits for this asynchronous method to finish executing. It temporarily pauses the execution, the flow of your code. And after we have instructed the page to go to this URL, let's use the await page.evaluate method, evaluate, and store it in a variable. Let's call it result. And the page.evaluate method is the place where we need to do our data scraping work. And what this method does is that it evaluates whatever JavaScript code within this function in the context of the page that you instructed to go to. For us to scrape data, we need to do a lot of document.querySelector and getting the text content of different elements. And the context of the document object within this page.evaluate method is going to be within the URL that we have just instructed the page to go to. So in this case, this URL right here. So this page.evaluate method is going to take an anonymous function, and within this function, let's just first declare a list of daemons variable and initiate it to be an empty array. And if we go to the page that we wish to scrape, and we already know that we want to scrape these guys. So if we use the developer tools and examine these elements, you can see that these are all anchor tags within a table data element. So with that knowledge, we can go back to our code. We can grab and store all those anchor tags within the table data elements in an array. More specifically, we can save all of them in a node list. So we're gonna call it list of anchors, and that's going to equate to document.querySelector all. And we're to know the selector is TDA. This way it's going to select all the anchor tags that are children of a table data element. So after we've done that, we're going to take the list of anchors node list and do an for each. And because the list of anchors, because the return value of a query selector all is going to be a node list, we cannot necessarily run a map or any JavaScript higher order functions that are meant to be working with JavaScript arrays. However, we can use the for each function to work with node lists. So we're gonna run the for each method on this list of anchors node list, and for each, let's call it item. We're interested in getting the item.text content, and we're going to push this item.text content into the empty array that we have just declared at the top of this anonymous function. So it's going to be list of daemons push. After we have run a for each method to push all the text content of each anchor tag into this list of daemons, of course, at the end of the page.evaluate method, we need to return this daemon name list. So we're going to return list of daemons. And after we have done this data scraping operation, we need to use the browser.close method to terminate the process of the browser instance. Otherwise, we're going to have a memory leak. And after that, we just return the result. We just return the whole page.evaluate asynchronous operation as the return value of this script daemon name list function. And after we have defined our script daemon name list function, let's use it by calling script daemon name list. And because we know that the return value of this function is going to be a promise, we're going to use the .then method to resolve the promise. Let's call the return value return val. And for now, we're just interested in seeing the result, so let's just console log it out so that we know that the function is working. And after that, let's go to our terminal and do a node index to run our script. And as you can see, because we instructed the Puppeteer to create a browser instance that is not headless, we're able to see the browser graphical user interface. And we can see that all the daemon name list is being returned, with the exception of the first one. And if we go to the browser and we look for this element, I don't know where it's coming from. It doesn't really matter. We can always clean up the data afterwards. So now that we know that the script daemon name list function is working, let's persist the data by saving it into a txt file. Of course, since we're talking about persisting data as text files, meaning we're going to use NodeJS to interact with the file system, we're going to import the file system module by doing fs equals to require fs. And within this .then function, instead of just console logging the return value, let's do a slightly more complex operation. Let's use the fs module and do a write file. And the first argument is going to be the name and path of the file that we're looking to save it under. So let's call it daemon name list.txt. And the second argument is going to be the data that we need to be persisting. So it's going to be the return val, and we already know that this one is an array. However, we cannot write an array directly to a text document, so we're going to convert it into a string by using the return value .join method, and we're going to separate each daemon name with a comma. The second argument is the data that we're looking to persist, and in this case we are joining the array where we're doing an array.join with a comma, so that it's going to write into this file a string of daemon names separated with commas. And the third argument is going to be our callback function. It's going to take two arguments. The first argument is going to be the error, any error that we might be potentially running into. And the second argument is going to be the data. And for now, I don't think we will run into any error, so let's not handle the error. Instead, let's just console log data written to daemon name list.txt. And now let's go to the terminal and re-execute the script. Index So now it's prompting us that data has been written to the daemon name list.txt. And if we go to visit the file, we can see that indeed we have stored a list of the daemons that we have scraped from this very page. So indeed we have scraped all the anchor text, text content into our txt file. And after we have acquired this list of daemon names, we can start scraping the information for each individual daemon. And the way that the Megami Tensei fandom.com works, how they structure the URL is that if you click on any of the daemons, for example, if we click on tote, it's going to go to this base URL / the daemon name. So if we take any daemon from this list, for example, if we want to go to, let's say, Odin, we can see the information of Odin, we can see the information of, let's say, Shiva, so on and so forth. And for each individual page for the individual daemon, we're interested in a few information. First of all, we need to scrape the URL of this profile image. So in this image, we're interested in the value of the source attribute of this image element. And the second thing that we need to get is the paragraph that is immediately beneath this history headline. And in order for us to do that, I have defined a new function off the camera by the name of scrape daemon info. And as you can see, it's following the same logic, as going to be reusable. So we can potentially use this function to run a loop on an array of daemon name lists. So for each daemon name, it's going to concatenate it onto this base URL, and it's going to scrape a few things. It's going to scrape the description paragraph and the value of the source attribute of the image tag. And at the end, it's going to return an object containing the name, the description, and the image URL. It's pretty much utilizing the same element, the same principles that we have talked about in the scrape daemon name list function. So to save you some time, I'm not going to bore you with the details. And inside of this index.js main script, we're just going to utilize the function that we have defined and save all of the daemon information into a JSON object. Alright, so because we have already saved the daemon name list into a text file, we're going to get rid of that block, all the code that is related to saving the daemon name list, scraping and saving the daemon name list. And let's now first test the feasibility of the scrape daemon info function. So we're going to comment out the execution related code and uncomment this function call, which pretty much just calls the scrape daemon info that we have declared, and just console logging out the return value. If we go to the terminal and call node index, and let's not use arrays, let's pass in the name of another daemon. Let's try to get the information of Thor. As you can see, it's going to spit back the formatted object containing 3 properties, which is the daemon's name, his description, and the image URL. And when we click on the image URL, it's going to take us to that very image. So now that we know that the function is working, let's recomment out this function call and uncomment this execution block. So all this code block is doing is that it's going to read this daemon name list text file and turn it into an array by splitting it at the separation comma, and it's going to call the process daemon list function, which is a customly defined recursive function on this array. And the process daemon list function is going to consume the list and call the script daemon info each time on the first element of the list. And after it has gotten the return value, it's going to save it into a JSON file by the name of script daemon info.json, and it's going to get rid of the first element of the list and call itself again, this time passing in the list without the first index, so on and so forth, to the point where when there's no more items in the array of daemon names, it's going to save everything into conclude the saving of all the daemon information into this JSON object and just finish executing this recursive function. And the reason why am I doing this is because since we have over 400 daemons, if we start operating on the scraping of the information of all of the 400 of daemons at the same time, it's going to crash the browser, because even opening 20 tabs at a time is going to significantly slow down a browser, let alone opening up 400 tabs at the same time. I'm sure there are ways that the library exposes to you to let you set the limit of how many browser tabs you want to open at the same time, but I didn't want to do the research, so I'm just using this recursive function to script the daemon information individually, one at a time. And let's quickly clean up the name list to make sure that there's nothing that can potentially crash it, because the first element of the string is definitely not a daemon. It's probably some paragraph tag that we have failed to clean up. So let's save the file and make sure that everything looks okay and just execute the script. Let's do node index. So it's going to tell you that you have, this is the length of the array, right? And it's going to start scraping all the daemon information one by one. So to not bore you with the detail again, we're going to fast forward to the point where we have done scraping all the daemons. Alright guys, we have now successfully scraped and saved all the daemon information objects into a script daemon info.json file. I have migrated into the data folder of the front-end React project that I have created behind the scene using the Create React app. And I've also took the liberty to define a daemon card component, which is a functional component that takes the incoming data, which is a daemon object, and maps out the image using the image URL property of the props object, mapping out the relevant information, which contains the value of the source attribute of the image tag and the daemon's name and the daemon's description. It's going to map them all out as a card component without any styling though. And inside of the app.js, which is the parent topmost component, as you can see, for this project I had a lot of fun using the React hooks to manage state instead of declaring the app component as a class level component and managing the state using this.setState, all that kind of conventional way of interacting with the React library. This time around we're using the useState hook, and we're also using the useEffect hook, which effectively replaces the component didMount. And inside of the useEffect, we are looping over the daemon information object we imported from the JSON file and converting it into an array to save it in the state of the app component. Inside of the render method, we're looping over the daemon list array, and for each daemon we're going to render it in the form of a daemon card component that we have declared and passing in all the relevant information as props. And now let's try to run the app by running the npm start script, and it's going to spin up a dev server, and voila, all the daemon information that we have scraped is being faithfully mapped out into the browser. Alright guys, so that's all I have to talk about in today's video. I hope you found it to be informative, and I'll see all of you in the next video. Bye bye.